Hello everyone, this is Ashok, your personal guide and mentor. I welcome everyone to my YouTube channel AKB Tutorials. Here we are going to discuss and cover some important concepts of mechanical engineering that are very useful and helpful for competitive exam and job interviews. So let us start today's session. Hello everybody. So today in this lecture we are going to see one of the most interesting and important topic of strength of material. Though the students are making a lot of mistake in this kind of problems. So today we will clear our concept in this topic. Today's topic is principle of superposition. So what is actually the principle of superposition? If a body is acted upon by number of forces, that is P1, P2, P3, P4, Pn, at different segments of the body, then this problem is coming under principle of superposition. Earlier we have seen a problem on stepped bar, but the load was same for all the segments. But here the loads are different for different segments. So what is the net effect produced by different loads acting independently in various segments, we will see here. Now for this first step, we have to draw the free body diagram of the body. So we are marking the sections or segments as 1, 2 and 3. Okay. Let the L1 is the length of first segment, L2 is the length of second segment, and L3 is the length of third segment. And the respective areas are given as, say, A1 is the cross-sectional area of segment 1, A2 is the cross-sectional area of segment 2, and A3 is the cross-sectional area of segment 3. Also, if the segments are made of different material, then say E1, E2 and E3 are the Young modulars of different segments. So this much is given, but in first step we are going to draw the free body diagram to see what is the exact force acting in different segments. Okay, so if we draw the first section, so this is the first section. So in this it is seen that P1 load is acting towards left. So what is this kind of load? What is the kind of load acting on segment 1? That is tensile load. If this side it is acting P1 load, so this side also will be P1 load. Okay. Now we will see the section 3. So if we see the section 3, that is P4 load is acting outward. So once this load is a tensile load acting in segment 3, then this side load also will be P4. So it is confirmed that segment 1 is under tensile load and magnitude of load is P1. Segment 3, it is under load P4, it is also tensile load. Now the middle part, that is the segment 2. So we are drawing the segment 2. We don't know what is the exact force acting on this segment. Let say X and tensile load we are considering. Load X is acting on this segment. Okay, so if left side is x, right side also will be equal to x. Now P1 and x are the loads, that means these are the vector quantities. So if we find the sum of these two vectors, two parallel forces acting, so for timing, if P1 is greater than x, then what is the magnitude of load towards right is acting is P1 minus x load is acting towards right, and that is given here as P2. Okay, P1 minus x is equal to P2. Say this is equation number 1. Similarly, if P4 is greater than x, P4 is acting towards left and x is acting towards right. So at this interface, what is the sum of the loads is P4 minus x, and that will be equal to P3. Okay, from here, by solving these two equations, so we can get x value. So by solving these two equations, we can get x value. So we will get x value. So once this becomes x, this also will become x. Okay. So by this way, we will solve what is the load acting over each segment. So in first segment, P1 is the load acting and the nature of the load is tensile load. In third segment, what is the nature of load is tensile and magnitude of load is P4. And in second segment, what is the load acting, that is x, and nature of load it is tensile. But if x value is negative, then it will be a compressive load. Okay, so that x value we will obtain by equating P1 minus x is equal to P2 and P4 minus x is equal to P3. By equating these two equations, by solving these two equations, we will get the value of x. Once we get the value of x, then what is the exact load acting on segment 2 we can determine. So after this, so we have got the value, that is what is the load acting on segment 1, segment 2 and segment 3. Okay, the other parameters are given, that is L1, A1, E1. So we are taking this, say the segment 1. Here load acting is P1, okay, and the length of the member is L1 and cross sectional area of the member is A1 and the Young modulus of elasticity of the member is, say, E1. So once all the parameters are known, what is the deformation produced in this segment 1, say it is given by dl1. Load is tensile load. So we can write what is dl1 value, P1 into L1 by A1 into E1. That is the deformation produced in segment 1. Similarly, what is the deformation produced in segment 2? So load, tensile load, it is acting and the magnitude of tensile load is x and the length of the member is L2, area of cross section is A2 and Young modulus of elasticity is E2. So we can write dl2 is equal to P2 into L2 by A2 into E2. And in the similar way, we can find dl3 is the deformation produced in segment 3 is given by what is the load acting on segment 3 is P4 into length of segment 3 L3 divided by cross sectional area A3 into E3. So here we have seen that all the loads are tensile load. If X value is negative, then it may be compressive stress. So because of compressive stress, deformation will be negative. It may be. If X is negative, so sorry, not this one P2, this is X. X into L2 by A2 into E2. So we have got the deformation of respective sections. So total deformation of this variable section bar, total deformation produced in this variable section bar is given by dl is equal to, you can write dl1 plus dl2 plus dl3. So this one may be negative also. If the X value is negative, then dl2 will be negative. So we have to take care in this point. Now we will see some problems on this. The first problem we will see here, that is on the principle of superposition problem. So we have seen the theory. Now we will see one problem. Say a uniform bar, it has three segments, and the respective forces are given. The forces at the right, it is 21 kilonewton compressive. Now at the left it is 63 kilonewton, and at the interface that is 35 kilonewton, and here it is towards right 49 kilonewton. And the segments, the name of the segments is given as P, Q, R, S. Now question is, a bar having cross sectional area, so uniform bar, cross sectional area of section 1, section 2 and section 3. So if we mark here 1, 2, 3, all the sections are of same area. What is that area? Area is given as A1 is equal to A2 is equal to A3 as 700 millimeter square. Okay, and the axial loads at different positions is given in the figure. Find the value of stress in segment. Find stress in segment QR. So in the middle section we have to find the stress value. So to solve this problem, we have to draw the free body diagram first. First we will draw the free body diagram of segment 1. Say this is the segment 1, second one is the segment 2, and third one, that is segment 3. So we can see this one is 63 kilonewton. So the load acting on element 1 towards left, that is 63 kilonewton. So this one also will be 63 kilonewton. Now you see the segment 3, it is given 21 kilonewton. So from this side, because this load is a compressive load, so here also from left side it will also be compressive load. So in first segment, so you can see 63 kilonewton, that is tensile load, and in second one it is third segment, it is 21 kilonewton compressive load. Now let in second segment we don't know what is the force acting. Say the force acting here is x kilonewton, and this is the segment 2. Now the sum of these two forces, that will be equal to 35 kilonewton. So that means 63 kilonewton towards right minus x kilonewton which is acting towards left, two parallel force. So that will give 35 kilonewton. So from here we can get what is x value. So x is equal to 63 minus 35. Okay. So what is coming? 28 kilonewton. Okay. So left side x value is coming 28. So right side also will come 28 Newton. So let's see. Here x is acting towards right and 21 is also acting towards right. So sum of these two will be 49. So x plus 21. So x is also acting towards right and 21 kilonewton is acting towards right. And this 49 also shown as towards right. So x is equal to 49 minus 21. So it is coming 28 kilonewton. So it is clear what is the force acting in segment 1 or segment 2 or segment 3. So we can write separately here. So the first segment is under 63 kilonewton tensile load, first member, that is 63 kilonewton a tensile load is acting. Second member, this is the second member, it is under 28 kilonewton, it is also tensile load. And the third member or third section, in this section 21 kilonewton is the compressive load. Okay. Now the problem is you have to find the stress in segment QR. So QR, this is the segment QR, that is the second segment. So in this segment, what is the stress developed? So stress developed is given by sigma is equal to load by area or resistance developed by area of section 2. So what is load acting or resistance developed in second member? 28 kilonewton into 10 to the power 3 Newton divided by area is given as 700 millimeter square. So 700 into 10 to the power minus 6 meter square. So the result is this. So you can just calculate this and you will get the result. So 28 into 10 to the power 3 by 700 into 10 to the power minus 6 meter square is the answer, that is Newton per meter square. Okay, so now we'll see the second question. A steel bar of cross section 500 millimeter square is acted upon by by the forces shown in the figure. Determine the total deformation of the bar. Determine the total deformation of the bar. Take E is equal to 200 gigapascal. So we know what is Pascal. Pascal is Newton per meter square is called Pascal. Gigapascal. So 200 into 10 to the power 9 Newton per meter square. That is 200 gigapascal. Now the problem is the loads are acting at various segments. So the bar, steel bar, it is having 3 sections. First section, second section, third section. Length is given as 0.6 meter, 1 meter and 1.25 meter. So the lengths are different and cross-sectional area throughout it is given as A1 is equal to A2 is equal to A3 is equal to 500 millimeter square is equal to 500 into 10 to the power minus 6 meter square. Second, the E value throughout is same, that is E1 is equal to E2 is equal to E3. We can write is equal to 200 into 10 to the power 9 Newton per meter square. So we know L1, A1, E1, L2, A2, E2, L3, A3 and E3 values. Only thing we have to get the P values. So P values in the problem is given at different segments as 50 kilonewton. Here it is given 15 kilonewton. Here it is towards left 10 kilonewton and this one towards right 45 kilonewton. So first we will draw the free body diagram of this body and name of the body is given A, B, C and D. So AB, BC and CD, 3 segments. So respective forces are given. So if we draw the free body diagram of this, first we will see AB segment. So this is AB segment. Now here towards left, that is how much load is acting? 50 kilonewton. So towards right also will be 50 kilonewton. That is segment 1. Now we will see the segment 3. So for segment 3, so load acting is 45 kilonewton. So this also will be 45 kilonewton because it is tensile load, so it will also be tensile load. This is segment 3. Now draw segment 2. So for segment 2, we don't know what is the force acting here. Let a tensile load is acting whose magnitude is x. Tensile load whose magnitude is x acting. Now if we add these two values, the addition of these two forces will give 50 kilonewton towards right minus x kilonewton which is acting towards left and that will be equal to, in the direction of this, that is 15 kilonewton. So that means x becomes 50 minus 15, that is 35 kilonewton. So we can check from here also, that is 45 is acting towards left. Okay, so 45 towards left minus this one is acting towards right, x is equal to this one is acting towards left is 10. So in the direction of this, so this is towards right, so this is towards left. Okay, so x is equal to 45 minus 10 is equal to 35 kilonewton. So that means we have got the segment 1 is under 50 kilonewton load, nature of load is tensile. Segment 3 is under tensile load, the magnitude is 45 kilonewton, and segment 3 also under tensile load, whose value is 35 kilonewton. 35 kilonewton. Now we are going to find the deformation produced in respective sections. That is, in first section, what is the deformation produced? Each dl1 is given by P1 into L1 by A1 into E1. So what is P1 value? 50 kilonewton, 50 into 10 to the power 3 Newton. What is L1 value? It is given as 0.6 meter divided by what is A1 value? A1, A2, A3 are same, that is 500 into 10 to the power minus 6 Newton per meter, 500 into 10 to the power minus 6 meter square. Into E1, E1 is same, that is 200 into 10 to the power 9. Okay, so that is Newton per meter square. So if we calculate this, the value will come as 0.0003 meter. Now we will see the segment 2. So the deformation produced in segment 2, it is given by dl2 is given by P2 L2 by A2 E2. So P2 is 35 kilonewton, 35 into 10 to the power 3 into the length of segment 2 is 1 meter divided by area is same, that is 500 into 10 to the power minus 6 meter square into E2 is also same, that is 200 into 10 to the power 9 Newton per meter square. So for second section it is coming 0.00035 meter, and we will see the last section, that is segment 3. So for segment 3, say the deformation produced is TL3 is given by P3 L3 by A3 E3. E3 is or 45 kilonewton, so we can write 45 into 10 to the power 3 into L3. L3 is given as 1.25 meter, 1.25 divided by A3 is equal to 500 into 10 to the power minus 6 into E3. What is E3 value? 200 into 10 to the power 9. So it is coming as 0.000.00056 meter. So we have got dl1, dl2 and dl3 value. So what is the total deformation produced in the bar? Total deformation is given by say dl, and that is equal to 0.0003 plus 0.00035 plus 0.00056 is equal to 1.21 meter. So millimeter. So it is in meter. Now convert it to millimeter. So total deformation produced in the bar is 1.21 millimeter. Okay friends, this is all about this video. I hope these problems, the fundamentals of these problems are clear to you. So before solving this problem, you have to draw the free body diagram, then the problem will be very easy to you. Okay, all about this video. Thank you. We will meet you soon. That's all for today's session. We would continue further on this topic in the next session. Keep being connected with us and ask any question in the comment section. Like, share, subscribe, and don't forget to press the bell icon to get notified for future videos. Thank you and see you soon.